Jai Hind everyone. Myself Gaurav Srivastava, Assistant Professor in Electrical and Electronics Engineering Department, Ajay Kumar Engineering College, Ghaziabad. And today we have discussed about the subject fault analysis and power system. And this subject is known as the, you can say, the power system 2, which is subject code BEE 601 for the 6th semester student of electrical engineering, as well as the electrical and electronics engineering related to the AKTU University affiliated to the colleges. So right now the power system 1, we have discussed about lot of what is the different components of the power system which are using, like inductance, capacitance, resistance, and there is something you can say the measurement about what is the corona, what is the corona losses, and everything related to the initially level of the power system. And now the second step we go for the power system 2, that is known as the power system analysis. And power system analysis, and now it's the first, there is a 5 unit related to the power system 2. And the first unit known as the fault analysis in a power system. So we have discussed about lot of discussion, what is the fault analysis, there is a something different type of fault, you can say symmetrical fault, unsymmetrical faults, and what is the criteria, what is their conditions, and then after we have discussion lot of another things which is related to the fault analysis in a power system. So first unit where we discuss about, there is a no mention that is the per unit system, we are directly going for the symmetrical components, that is known as the significance of the positive. What is the symmetrical component, their significance, their importance, and then after we get discussion about what is the negative and the zero sequence, positive sequence components, and after that average of the 3-phase power system in terms of the symmetrical components, they are the sequence impedances and the sequence network. That is the 4 topics related to the fault analysis, and then after we go for the fault calculation. So fault calculation, there is a sequence network equation, single line to ground fault, line to line fault, double line to ground fault, 3-phase fault, fault on the power system with fault impedance, without fault impedance, reactors and their locations which are used for the fault protection point of view, and short circuit capacity of a bus. So that is the unit 1 completely covered all the topics related to the fault analysis. And then we go for the we have discussion about more whatever the second topics, third topics, and the unit 4, 5, whatever the topics covered in this overall these subject. Like in the first unit we have discussion the load flow analysis, fault analysis, and now second unit is related to the load flow. What is the load flow? There is the introduction, need for the load flow. There is a, you can say, the different types of buses which are using for the load flow analysis, load dispatch centers and their operating strategies. You can say the formation of the Y bus and the just jet buses, and then we develop the load flow equations. Like there is a what is the active power and the reactive power, how can they can be controlled, or you can say the for the next generation point of view or the new future plan point of view, we have more discussion about how we can control the power generation and the power requirement for the flow point of view. And also in this, then we find out the load flow analysis using the Gauss-Seidel method, Newton-Raphson methods, and fast decoupled approximation, whatever the taking the Newton-Raphson methods, and there's a combination, you can say the find out the comparison between the Gauss-Seidel and the Newton-Raphson methods, introduction to forward, backward, and the sweep load flow analysis for the related network. So there's another topics which are covered in the unit 2, that is known as the load flow analysis. Then goes for the unit 3rd in a power system 2. So that unit belongs to the traveling waves which is generated on the transmissions lines whenever we had discussion in the power system. So there is a production, what is the traveling lines, their production, their end point of view, like open circuited line, or you can say the short circuited line, and then after there is a line termination. Line termination depends on the where the end point is. Initially we have started at the generation point, but what is the second criteria where the line is terminated? Line terminated through a resistance, line terminated through a cables, capacitor, T junctions. So moreover there is a something diffraction, and then we have find out the diffraction and the refraction point coefficient for all over the transmissions line. Then attenuations and Bellevue lattice diagram, which is also known as the multiple, you can say the bifurcations. And then unit 4th we have discussion about what is the stability in a power system. So initially we have discussed the power load fault analysis, and then we have discussion the load flow analysis and traveling waves, and then after the fault is generated and how we can improve our system, or you can say the stability after, because whenever the fault is conducted, what will happen, the system is unsynchronized or unstable. How we can improve our stable our system. So that point of view we have discussed in this chapter. So power low flow through a transmission line, stability limit, and then you can say the steady state. So different type of stability which are discussion, like a steady state, dynamic, and the transient. And transient, there is a swing equation we have discussion. What is the swing equation and their derivation, transient stability by the equilibrium criteria. What is the different factors affecting the steady state stability, similarly the factors affecting the transient stability, methods of improvement of stability. So there is a lot of content we are discussion in the further lectures. So wow, and that is the last unit that is related to the protection point of view. So basically, no, it is a very big unit, but there is a something you can say the scrap, or you can say the short content about the protection point of view, which is covered in a introduction to power system protection, in which we have discussed about relays. What is the relays? Their operating principle, general construction, basic different type of terminology. You can set the simple definition. What is the relay, energizing unit, setting, pickup relay क्या होती है, dropout, flag, fault clearing timing, breaking timing, overage, underage. So these are something small definitions which are used generally used in a power system protection. And then we have discussion about classification of the relays, and the classification of relays mostly 7 types, but in our syllabus that is a there is a 2 type of classification described according to the applications and according to the time. So, and then after we have discussion about small like overcurrent. What is the overcurrent relays, their classification, distance protection, differential protection. So that is the relays part, and another part of the protection is the circuit breaker. So circuit breaker, what is the circuit breaker? Their arc phenomena and arc extinction and different types of methods. What is the restricting voltage, recovery voltage, circuit breaker rating? There is a small content about the something you know that the power system protection is a completely, you can do the complete whole one subject, and this subject is just compressed in a one unit. So there is a lot of small introduction and the part of the sub topics which are covered in this unit. So now we have discussed about first unit. So fault analysis in a power system, and there is a something आपके पास we have find out कि हाँ whatever the content we have covered in this lectures. So symmetrical components, and then we have the power calculation of the symmetrical component, then sequence, what is the sequence networks and the sequence impedances, and then we find out the symmetrical and unsymmetrical fault. So there is a something like unsymmetrical, you can say the series and shunt fault basically defined, and like series fault we can say the one conductor or the two conductors test faults होते हैं, and similarly the shunt fault that is called a symmetrical and the unsymmetrical. So like unsymmetrical fault is known as the LG, double L, double LG. So that types of fault is called as a symmetrical, unsymmetrical, and triple L or the triple LG is known as the, you can say the symmetrical fault analysis. And then we have discussion about faults on the power with fault impedance or the neutral, and similarly without fault impedances. So we have the multiple options to calculate the fault analysis, and then find out the reactor. What is the reactors? What is the different locations, like connected as a generator point of view, generator as a transform bus bar ke accordingly, there is something transformer ke accordingly, motors ke accordingly. So the different locations where the reactors can be installed and removing the and less. Then find out the short circuit capacity. So before going on a fault analysis, we have initially discussed what is the structure of power system, because we don't go for the directly, we have to know what is the one line diagram, what is the impedance diagram, what is the reactance diagram, then we will go for the per unit impedances. Okay, how we calculate the per unit impedances in a single phase system or a 3-phase system. Then we go for the symmetrical components, because without analysis of the per unit we can't go or analysis the fault analysis, or you can the symmetrical components. So no, normally, namely, we goes for the power system. We know that one line diagram, it is just known as the power system structure, where the generation to the distribution point of view, how we can generate the electric power and how we can utilize this power in their load terms point of view. So like generating stations, transformer and the transmission line, they are the three main components which are called as the electrical power system. Initially in this diagram you can see that we have generating the stations at which the power is generated at 11 kV or the 25 kV electricity we will produce, and then what will be done, and this energy electricity produces and transmit to the another level, and this energy, or you can say the voltage level, will be increased by the transformer with the 220 kV and to the 6765 kV, depending on the HV transmission or HVAC transmission. Whenever we know that the power is generated at that particular location, and this all the power which cannot utilize at that particular location and we transmit to the another location for the utilization purpose. So there are two chances. There is a two options are available for the establishment of the, you can say, the generating plant. The first point, the first location is what is that? The first location is that where we can establish the load plant, where the coal, or you can say energy resources is available, and then we transmit this power to the another locations. And second option is that we go for that location where the requirement of energy is required, and we transport all the coal or the resources, energy resource, to that location particularly. So all, whenever in both the cases we have to use the transmission level point of view for the utilization purpose. And then after we have again transmit, sub transformer is utilizing to the sub transmission level. So like there is something like we have generating the 11 kV to the 25 kV power, and then it's transmitted also the step up transformer using through the tie lines to the other substation systems के साथ connected है. Then after the 765 we have transmitted and using the sub transformer, you can say the step down, where this transformer is reduce the voltage level to the 765 to the 33 kV to the 130 kV dV, depends on the large consumer like hospitals, industries, many other education institutes where the bulk power is required for the manufacturing industries. So that is the power transmitted, and then again there is a something like again a step down transformer which are using for the medium life consumers. So that is a voltage level ki हाँ जो आपका voltage level we have find out to the 33 to 130 kV, that is reduced to the 415 to the 240 kV volts. So like in this our home appliances, or you can say the small industries which are using the single phase or the three phase power with a voltage of the 240 volt and the 415 volt. So that is known as the systematic diagram which is known for the power system. So here we can say the generation station that is transmitted to the transmission line through the transformer, and then after they are distribution to the sub transmission level where the large consumers are available, and then again we further step down this voltage level which are used for the distribution level point of view or the medium large consumers, and then after this is reduced to the small consumer like homes. So that is all about the power structure of the power system. So like in each and every stage the voltage level is changed. You see that the where initially we have started to the 11 kV, then after again implemented through the step up transformer, voltage rises, and again transmission level voltage is step down, again level, and the end point of view there is a 415. So every stage there is a different voltage level, and that's point of view there is a lot of calculation whenever the fault is generated or something else, we have to discuss combined to a one level platform. So that's why we are using the per unit impedance, per unit calculation. So like in the previous diagram we have discussed one line diagram, and then I just shown in that diagram we have discussed about voltage level changes at every stages, and when we have discussion about more complex power system, what will happen? There is something like uh, different voltage level at particular sections. So we have, whenever calculation is going on, so there is a lot of calculation is very fast and the very large calculation is going on. So that's point of view we have just using the per unit system, and all the voltage level changes at certain equivalent point of view for the calculation point of view. So like there is a introduction about what is the per unit system. So normalization in electrical quantities using the chosen एक base value makes analysis independent of the voltage level कि लैब जो आपका changes होता जा रहा था voltage level हर level के ऊपर interchange हो रहा है वो हमने completely change कर दिया scenario. We have just checking a base, we have to selected a voltage base and then accordingly we have changes the per unit impedances for that particular all the sections. So like consider a single phase diagram. If we check this, so where we can choose the base voltage is the VV voltage. And similarly, base ampere, whatever is the base ampere we have chosen, that is the VAB. So that's point of view we have shown as the VAB. Then what will happen? The base current will be IB, that is the VAB by VB. And if we calculated the base impedance, then we can calculate the base impedances. Base impedances like ZB is equal to VB by IB, and then again if we put up the equation VB square by VAB. So that is the calculation for the Z base. And what will happen if the Z base, if Z is given, so how you will calculate the Z base? So if Z, then Z per unit, how? Because we have to go for the Z per unit. What is the per unit? So Z per unit is given by the Z upon Z base. So for any system, if the impedances is given, we have to calculate the base impedances and then after we can find out the per unit impedances, which is known as the base value upon the base value of that particular. Okay, and then similarly we can find out the ki Z upon Z base VB square VAB. Like, so that is the system for the per unit impedances. And similarly, if there is something like volt ampere is given in the kVA or the MVA, similarly, because we know that the whenever discussion about voltage or the transformer rating, so the certain rating is given as a like 10 MVA transformer rating MVA, and like there is a voltage level is 11 kV. So whenever we have just using these formulas, like for the base impedances, we have to convert this MVA into the kV. So like kVA, so thus kVAB, and so we have find out the base impedance is like this. Okay. So that is the Z per unit impedances for the single phase system we have to calculate it. And now we have similarly calculated the base impedances or the per unit impedances for the three phase system. So like three base system, we again choose the base three phase base voltage magnitude volt amperes. Like what is the MVA base? Base MVA we have selected volt ampere. Similarly, base voltage we have choose क्योंकि three phase का we have utilizing, and for the star connections If we select the find out the base current, that is IB, what is given as the, because something like MVA, so we have to just change the MVA into KVA. That's why we have multiple with the 1000, and then the value will be root 3 into KV by KVB. So base voltages in terms of the kilovolt we have put up, and similarly the MVA rating, base rating, which is given in the MVA. So right now we have convert to the value of the KV in terms of multiplying by the 1000. And then what will happen? Base impedances, if we calculate it, so base impedances we have calculated like ZB is equal to root 3 IB, and put the value of the IB. What will happen? So Z base calculated, and then Z per unit is equal to Z upon ZB. So simple, that is the Z into KVAB upon KVAB square into 100. So that is a diagram for the per unit calculation. If there is something like we have the formula for the single phase and the three phase system, and we have calculated the Z base, then what will happen if we change the level? Like that is something like voltage level at that point we have find out the base impedances, and then after voltages changes, what will be the new updated value of the per unit of the system. So that's point of view. So for the new base system, we can find out the formula Z per unit, new Z per unit old into MVA old So MVA new upon MVA old into KV old by KV new square. So that is the per unit value of the new system if the old per unit value of the old system is given at. So we have discussed more about the formulas, or you can say the numericals in which we can utilize this type of formulas. So main advantages we have discussed about what is the advantages of the per unit system. We can say simply the simplifies calculation because of a motive of that, because of the lot of voltage levels changes at the certain ratios and the different power ratings of the different electrical components which are used here. So all the components or the quantities that on the same level we can use the per unit system. Make comparison is easier. What will happen, which is find out avoid conversion across voltages level, reduces chances of error in the complex network, because in a one or two problem system, 1, 2, 3 bus system, there is a no problem. But when we are going for the large substation or the complex power system analysis, we have the very chances for the you can say the errors, and we can using the per unit system to reduce this type of errors in that particular section. So like now that is something one numericals here we have discussed about. So there is a one line diagram is given, if you seen that. So that is a one that is a generator side where the power is generated, and this generated power transmitted to the through this transmission line using there is a T1 and the T2 initial and the final stage of the transformer, and there is a something motor is connected. Two motors are connected at the bus 2 and the 3, and there is a something there is a circuit interconnections diagram is also given at the generator 1 is the neutral grounded like simples, and there is a bus 2 and the bus 3 is the neutral, you can say the neutral impedance is grounded, and there is a transformer is the star grounded and the star grounded both side, there is a primary side, and the secondary side there is a primary connection as the star grounded and the secondary connection is the delta. So the different values is given, like generators G1 value is given like this, there is a certain MVA ratings 30 MVA, and there is a voltage level is 10.5, their reactance is given as the 1.6 ohm, and similarly generator 2 is given 15 MVA 6.6 kV, reactance is 1.2 ohm. G3 value is 25 MVA 6.6 kV, there is a something 56 ohms, and there is a transformer which are using here. So initially there is a voltage level 33 by, if it's seen that the 11 kV, and secondary 15 MVA, and the T2 is transformed, that is the 33 by 6.2 kV. Transmission line there is something 20.5 ohms per phase is given as, and the A is given and the B is given the power 15 megawatt, and the 40 megawatt within the voltage level is 11 kV, and initially there is a 6.6 kV boom. Oh, sorry, A 11 kV, and there is something 6.6 kV. So like here you can say the generator voltage is 10.5 volt at the bus 1. If you seen that is a bus 1 connection, and that is a bus 2 connection. So there is a bus 1, there is a generator is connected 10.5 kilovolt, and then similarly the load 1 is connected taking the power from the bus 1, and that voltage is 11 kV. What will happen? There is a transformer T1, that is the ratio is given like this 33 by 11 kV, and similarly transformer 2 के लिए transformation ratio this. And for the motor 2 and the generator 2 which are connected at the bus 2, that is the voltage level you can say the 6.6 kV. So in this diagram you can see the voltage levels are changes continuously from starting point to the end point. So here we can find out the one line diagram for that system, so that each and every selected, so the common base system and the common voltages, or you can say the generator point of view, then each and every system can be finalized. Like here we collect the common base MVA, that is the 30 MVA, and similarly generator and voltage base, because in each and every numericals whatever the power system analysis we can do, there is a something like we have to select their own common base or and common voltage basis, or you can say the common MVA base for the complete system, so that the complication and the calculation can be easier. So like we have chosen the common base 30 MVA and the voltage base is 10.5 kV in the generator circuit. What will happen if we seen, so there is a we have to find out the voltage. So we have discussed about ki common base, we have to select the common base for the whole the system, like, so that is also called as the new base system. So we have selected the new base system for all this one line diagram, and similarly we have taken the base voltage. So that is our choice, what will we select, base voltage at the generator G1 point of view, or you can say the transformer T1 side, T1 T2 side, transmission line, motor 2, motor generator 2, or the generator 3, depends on our choice. Here we can, in the question the voltage base is given as the 10 point selected kV in the generator circuit. If we find out the generator circuit, then what will our next step to be calculated? So we have to find out ki like base voltage in generator G1 is equal to what will happen? So this voltage is equivalent to the primary side of the T1. We can write it similarly. Primary side T1 voltage is we can write, and which is also equivalent to the what will happen? So that is a 10.5 kV voltage. Similarly, that is the voltage for the load A. लिख सकते हैं, we can simply write, because we have selected the base voltages for this 10.5. So this voltage is equivalent to this, and this is equivalent to the primary side of the T1. And now we have to calculate base voltages in secondary side of T2, secondary side of T1 transformer, which is equivalent to the voltages. जो यहाँ का voltage होगा, that is the same voltage for the transmission line, equivalent to the voltage at transmission line, and it is also equivalent to the this voltage to the primary T1 side of the primary side of T2 transformer, which is calculated through the using the transformation ratio, like 10.5 into 33 by 11. What will happen? Just do the simple calculation. So that is a 3. So 3 पंजे 15, 3 30 और 31. So that is the voltage find out. So that is the voltage at the primary side of the this. And now we have again find out the base voltage in secondary side of T2, which is equivalent to the base voltage of the G2, G3 and load B, which is equivalent to again, क्योंकि यहाँ पर 31.5 आ रहा था voltage, and then यहाँ पर transformation ratio लगा हुआ है 6.2 divided by 33. So here we can simple calculate it. So there is a calculations. So we have to practice about calculation. You have to calculate using the calculator. 31.5 into 6.2 divided by 33. The voltage is 5.91. So initially we have calculated the MVA base for the complete system and find out the base voltages for the each and every component, and then we go for the analysis. So just take in new slides, like here again the value is given. So we have calculated the jet per unit new. We have the formula jet per unit old into MVA new upon MVA old into KVA old upon KVA new. So individual steps, like we have to calculate Z PU. So आपका what is the generator 1? Initially impedance is given is like this. What will the value is given? 1.6 ohm. So like 1.6 into MVA new, you have a MVA new value. So like 30 MVA, and इसकी वैल्यू कितनी दे रखी थी आपकी 30, 10.5 अपॉन 10.5 स्क्वायर, क्योंकि अगर आप देखेंगे तो जनरेटर 1 की वैल्यू आपकी वही थी, क्योंकि हमने जनरेटर बेस जो वैल्यू सेलेक्ट किए 10.5 दे रखी. तो आई थिंक सेम वैल्यू वी हैव कैलकुलेटेड अगेन हियर. Similarly, we have calculated Z per unit T1, Z per unit T2 jet per unit TL. Transmission lines के लिए basically we have to calculate it. The what is the value is given is the transmission line 20.5. So 20.5 into voltage level. So transmission line का voltage कितना निकला था? We have to find out voltage as a transmission line 13.5. Generator 2 we have to calculate, generator 3 calculated. Similarly, we have to calculate load A and load B. सबके आगे we have to calculate the value new. Then after we can draw the impedance diagram, or you can see the, so like generator we have this, transformer G1. Similarly we have to calculate it, the यहाँ पर आपका वो भी लगा हुआ है, load भी लगा हुआ है. Then T1 transmission line, T2 तो यहाँ पे आपका generator T2, generator 3 and load B. So there is a one line diagram, you can say like that is the impedance diagram of that numericals. Then after we can discuss about symmetrical components, and because there is not a neutral impedance is given connected, so that's why that is open, and similarly there is something ki that is connected to the ground, so this connection will be connected, otherwise they will be open. So that is all about the per unit system, and further in the next lecture we have discussed more about that. Thank you.